Welcome to another session of Peterson Academy diaLogos. Many of our dialogues have been centered around philosophy and particularly politics as of recently. But today we got a special guest, David, and he's going to be talking about some of his studies, what he's been researching and learning through John Vervaake's course, Intro to Intelligence. And so this will be a dialogue where we dive into neuroscience, and the nature of cognition, intelligence, how we come to, and relevance realization. Uh, David is from Italy, right? All right,
That's
so we
right.
have David from Italy. Igor, who is a neuroscientist by profession. He is from Switzerland. He's going to be joining us as one of the listeners. Josh and myself, who you guys seen on this channel. Josh from Canada, myself from North Idaho. And then Parker is just lurking in the background as a listener, or as just a fly on the wall. All right, so with all that being said, David, take it away. Looking forward to this.
All right. So, let's say a few weeks ago, right? I don't know how it came to mind. That was ever since I discovered it through Jordan Peterson about the big five personality traits, right? Yeah, I've always been fascinated because of what he could afford in terms of understanding a person, right? I mean, not as in types, but in a more nuanced way. Something that always bothered me was openness. It never seems to really be coupled with all the other four traits, right? Openness, or if somebody doesn't know, explores intelligence, creativity, those kind of traits. But then I was never satisfied. And I don't know why I even had the idea, but talking more and more with people, right, and trying to understand, because I teach English, trying to understand them, trying to figure out how to talk to them in order for them to understand how to better assimilate the language. I come up with the idea that perhaps openness wasn't about being either creative or not. Perhaps it was about being creative on a continuum from two different points, divergent or schematic. It doesn't mean that one is either one or the other, but on a continuum, right? One could be more schematic, one could be more on a divergent side. And that started me off really trying to understand Vervaeke's lectures. This is what I was working on when I started to follow Intro to Intelligence. I had already seen his first course, Wisdom, Spirituality, and I don't remember the other ones, right? Which was very interesting. So I wrote a few things, trying to present to people to see if it would hold any water. I don't know if you read it, but it seems to work. But then something else happened as I was going on, as I was following the Intro to Intelligence. Vervaeke comes up with a problem, that we don't have a model for relevance realization, right? That's a huge problem. And I was talking to a friend of mine, telling her, like, yeah, that is the problem. We probably never figured that out. I talked to other people in some of my students in artificial intelligence, and I did tell them, like, we're probably never gonna ever figure that out. I thought if we figured that out, we might figure out how life began. I mean, if you think about it, if you remove the homunculus, you remove God in a sense. Basically, you push him back, right? Which is not something that I necessarily like, but then again. Okay, so relevance realization, what's the idea? Following Bickman's work, Bickman's courses, has any of you followed his courses on endocrinology or
I've
biochemistry?
only taken biology of his courses, just doing
Right.
the last lecture right now. So,
Oh, okay. No, those are
okay.
mighty interesting, aren't they? Right. So yeah, two things that might have nothing to do with each other. Who knows if this is true? But I thought about the action potential, right? So yeah, what is the action potential? Is how muscles contract, right? We know from the courses from the courses by Baland on neuroscience that just thinking about activating the muscle partially activates it, right? Thinking about practicing the piano already makes you better at playing the piano, roughly like 20% on average, if I remember correctly. Yeah, I think that's it. So I went, okay, what if relevance realization doesn't start on a conscious level? It starts on at the pre-excitation of those neurons before firing, like a cascade that propagates based on external stimuli from basic patterns that then excites more complex pattern and then excite patterns already embedded in your memory throughout the topology of your brain. And then the one that receives the most activation, once it reaches the threshold of minus 55 millivolts, wins. So, in a sense, right, I think mechanistically, it's not that I think it, that's what the idea leads, that's where the idea leads, is that relevance realization and predicting process, it basically emerged from the same mechanism, right? That's the core
Yeah.
idea, which propagates throughout the topology.
So to reiterate what you're saying here about, I like that. I watched that video you sent about the action potential, and that was a very interesting, almost very compelling video. So what you're saying is relevance realization is a phenomena or a thing that we can measure in the brain that emerges once the action potential reaches 55 millivolts, then it becomes relevant. But underneath that action potential, there's a lot of I hate to use the word unconscious, but maybe latent activity going on. Because in that video, it talked about how you say the word dog to artificial intelligence, right? Maybe even to a human. And when you say dog, a lot of other circuitries kind of light up, but not enough to reach the action potential, like cat, um, animal, and the one that has the highest potential wins. Correct?
The one that gets excited the most based on
Excited.
the topology, based on the kind of profession you do. If you're a veterinarian, other topologies get excited because they are connected. Because by Hebbian learning, neurons that fire together, wire together. So you create this this net that expands based on your prior experiences, based on your innate topology, how it is associated. Because also like other factors, like a kid. A kid says a cat and says dog. Why would a kid say dog? Well, perhaps all of the minute features that makes a dog, right, are still they are not yet learned to be parsed out between a dog and a cat.
Yeah.
You need to, yeah, you need to experience it more. You need to excite them more. Your occipital lobe V1 still has to build this topology in order to differentiate between the two, right?
Mm-hmm.
So you go like, okay, snout, ears, might be a dog, might be a husky, but then you hear a growl, then you see it against something that you could recognize it, so you can actually infer the size. No, that's much bigger than I thought. That's great. Yellow eyes. So now other things excite. Oh no, it's
Mm-hmm.
not a dog, it's a wolf. Right. And because then you're excited other things and other things lose. Right. Well, it's not that they lose or they don't get chosen. I mean, the what the feature is, which is a feature, it's not a bug. You just don't have enough, perhaps, maybe, you just don't have naturally enough metabolic fuel to excite the whole thing all the time,
Mm-hmm.
right? Then, yeah, then gets to danger. If you think it's a dangerous thing, it still has to be learned sometimes. Sometimes it's innate like a snake.
Mm-hmm.
So the pattern might already be there. Mm.
The salience for
So
fear.
that's how it might work. This could explain a few things. Like I don't know if you had a look at the stuff that I did write them with the aid of ChatGPT. Otherwise, I would never have been able. I'm just far too busy. But I did read them all, and what didn't make sense, I rewrote it and by hand. So what didn't align to what I was saying, I did that to write it by hand. So it would explain a lot more things, but I still not sure about if you can explain all the things all the ideas that I put down, because
Okay.
these things had to be
I'm gonna
taken with caution.
I'll add some philosophical language to what you're saying here. I just took the logic course, and they talk about this in lecture 2. They talk about sensations to perceptions to conceptions, and then language is built on top of that, and then paragraphs and then narratives and theories. It's and it's really interesting because some cultures don't have particular concepts. Like they can't conceptualize. They can't count past 3. They talk about the crows can't count past 3, and in some indigenous cultures in New Guinea, they don't have a number system. They just have they literally count the sheep that go out with rocks, and you ask them how many sheep are out in the field, and they'll say that many this many with the rocks to represent that. And what occurs there, argument from Ayn Rand in her book Objectivist Epistemology, what gets you from sensation, you go from sensation to percept. So sensation is raw input, just flooding over you, buzzing, mess of confusion. Then perception, you start to kind of make sense. There's something, this is where differentiation starts to occur, because this blob of sense data is not the same as that blob. There's separation, and it's different. And this differentiation also can occur, I believe, in the brain too. As the brain's getting wired up, you start wiring up different regions of the brain so it's proper. This happens in the 4th trimester. That's after the baby's born. 4th trimester is 9 months after their brain's still wiring up. And we know this. They're making when a kid first hears a sound, like babies, before the age of 2, they can pick up way more sounds than adults can. But in those first 2 years, the sound is getting pruned out. That's why all kids that are 2-year old will hear certain the rolling of a certain R syllable. But by the time they're 2 years old, they get the sounds get differentiated, so they can only hear things that are relevant to that culture. So Japanese kids past the age of 2 can pick up sounds that American kids cannot, and that's all happening before the age of 2. So there is this synaptic pruning that occurs. and then it turns into concepts. I think this is where maybe we're getting some convergence here with the idea of concepts, is when all those when the correct amount of differentiation has occurred in the mind, in the experience, and it gets bundled into a proper concept that's a placeholder. Now, with humans, we don't have concepts given to us innately, perhaps, or a priori. They are distilled by culture, by parents. They have to teach us. That's why certain cultures can't count. They don't have a number system. And so that would, in order for us to properly prune, properly gather the perceptions, the sensations into a proper concept, that requires something external to us to kind of do that molding. And maybe perhaps that's I just want to push that back to you. What do you make of that philosophy of
Oh
cognition?
yeah.
Okay.
Oh yeah, I mean, it might be that we did evolve so that a kid has much more synaptic connections because it has to
Mm-hmm.
do a lot of preparation during that period. Perhaps that's how we evolved. It has to do a lot of learning. So the
Mm-hmm.
quicker it is, the better, right? Right.
So
But
learning
then,
learning is synaptic pruning. Then learning is that getting the right action
mm,
potential that will fit with the environment, with the culture.
it might be that learning is not exactly the pruning process. It might be that pruning is the learning is the building and the confirmation of those connections, which get like larger. Like you
Mm-hmm.
confirm it in some way mathematically, like in a mathematical statistical, by mathematical statistics, right? Mathematical chance. You get excitation, so those connections widen and strengthen, while the rest that you don't need, it's not that it gets pruned, because who prunes it, right? It just gets reused, because what
Ah, okay.
you don't use gets reused,
Mm-hmm. To
right?
use okay, and it's
So
used for something more relevant.
maybe it gets taken down and
Mm-hmm.
used to build the connections that are already there, already functioning,
Mm-hmm.
already like trafficked, because nobody prunes anything. In fact, some people never get those connections pruned, at least in part. So they get what's that condition where they can see notes,
Oh,
right?
synesthesia or
Yeah,
mm-hmm.
synesthesia. Yeah.
Mm-hmm.
Mm. Somehow that doesn't happen. So,
So,
yeah. Oh, hmm.
well, no, also with a lot of I learned this from Norman Doidge in The Brain That Changes Itself with ADHD kids and autistic spectrum kids. He was going into the studies and kind of finding a correlation, not necessarily a causation, but a correlation to kids that are living next to airports and noisy environments, loud TVs and everything. They have higher correlation of ADHD and autistic like syndrome. And the conclusion that he draws from that is in the early ages, in the early stages of infant development, in a natural environment, when something like a tiger or someone would scream and go ah, and it would it's called the orientating reflex. So there would be a spike of acetylcholine to trigger the salience network to say pay attention to this, and with that flood of acetylcholine there's now much more malleability for more wiring to occur in the brain. Now, in a natural environment, that's adaptive because you want to learn when a lion is entering into your house or a bear or something dangerous occurs. You want that orientating. You want to be able to orient to that anomaly. But when we put our kids in an unnatural environment, loud, flashy TikTok screen or TVs or a loud airport, perhaps, what's happening, Norman Doidge speculates this, is that it's triggering the orientating reflex and causing an over wiring of the brain improper. And so what happens is they are overstimulated. and because they're taking in too much, they didn't wire up. They can't actually. They wired up their brain to always be on high alert, because that is what is being that's the culture, or that's the environment that they are getting put into, to that high orientating reflex, and that's maladaptive, and so they actually can't integrate sense data, conceptual things. They can't actually direct their attention later in life because that wiring was not done properly.
Makes sense with the
Yeah.
tokenization theory. Yeah.
Yeah. Igor,
Yeah.
you have a question. And you're on mute too. So.
Yeah, thanks. So I'm going to play the party pooper role.
Oh, sure. Go ahead. I need somebody
He's the academic. That's his
this.
role.
So just a very short background story. In my thesis, PhD thesis, I was trying to see if we could somehow locate structures that were responsible for a higher cognitive function, that is spatial orientation. So it's just to give you a broad overview. This is a skill, an ability that requires a lot of different, more basic cognitive skills. So in that sense, it kind of looks like relevance realization. I'm not claiming that it's the same process at all. Don't get me wrong. It's just that it requires many subcomponents of cognition, some of which are below our awareness level. Let's put it like that. So the reason why I'm telling you this is that in my thesis, one of the conclusions I draw is that pinpointing areas of the brain and saying this does that cognitive process is close to impossible. And if you look at the history of the literature about about all cognitive processes, there is a broad consensus about some areas that seem to be more specialized than others. But the more the research goes on, the more we seem to see that maybe it's not about so much what one special area does. It's what it does with other areas and with other inputs. So the issue there is jumping from the anatomical, broadly anatomical, to the cognitive. This is already a big challenge. This is already a big leap. And with your proposal, there are additional huge leaps on top of the one I was describing, because you're not only jumping from the broad, anatomical to cognitive, you're going from the sub-anatomical at the very unit level to the cognitive. And this is a big conceptual problem, because in what you would have to do in theory is have to suggest a mechanism that would allow you to take into account, that explain how you go from the neuronal level, from every step you take up to the cognitive. And this is very difficult, and one of the reasons for that is that studying the functioning and the firing of single populations of neuron in humans is impossible.
Yeah.
And in vivo, right? You can grow cells, you can have study cell in one way or another. I mean, human neurons, but to study them in a living human brain would be the gold standard. And doing that on a cellular level is not possible.
Yeah.
I'm not saying it will never be possible, but right now it's not.
Yeah, exactly.
Let's be clear.
Yeah.
So maybe one last point, this whole I was heading to, is to say that it's great to come up with a potential explanation, but I think in the end it should be something that should be testable.
Yeah, you're right. That's what I thought. But then my thought went to, like, for example, Darwin. He didn't have proof. Semmelweis with germ theory, he didn't have proof. It had a causal function. Einstein, he didn't have proof. It was discovered later that he was right. So it's, yeah, eventually you have to test it. That's why it's a theory. Right. I mean, Einstein's theory of relativity, they still call it a theory. They're still not sure. Well, I mean, they still call it a theory because it doesn't work with quantum physics. So it works well enough. Right. So yeah, eventually it's going to have to be tested. Not necessarily right now. If it can explain a multiplicity of things that might give at least posit to investigate. Right. You test it and test it. If it works for everything, it might still not be right. But if it works, it has a higher chance of being right. Wouldn't you say?
I mean, I definitely agree on principle, and I think what you're hinting at is that a scientific theory is always true until disproven. Exactly. So the thing, and this is going back to what I was trying to articulate, is for your theory to be testable, it would require accounts of how going from the cellular to the multicellular to the structural to the cognitive, it would have to have a tentative explanation of each of these jumps, and we would have to test each of these predictions based on the models you would suggest from each of these jumps.
I mean, you can test it. You could test it in a year, actually. You just build an LLM that works with the same topology and with the same affordances, with the same kind of stimuli, and see what happens.
So an LLM would, sorry, your claim would be that an LLM could have the same affordances than fully embodied humans?
Neural network.
If you built it that way through this kind of philosophy, right? And they already do. That's the thing. Propagation cascade. They already work that way. The only thing they lack is the ability to be plastic on their own. That's really the only thing they lack. Right.
They would also lack relevance realization.
Yeah.
So yes. So the point is, you want to try to figure out how relevance realization emerges on a system that doesn't have it.
Yeah, you have to make it more like a computer, though, because right now they're not built. Right now, what we do, right? We hack it. We go like, no, don't think about the object. Don't think about the tree. I'll tell you what the tree is. It's like the man in the cave, right? Like, no, don't pay no attention to those people outside. I'll tell you about them. You don't need to go outside the cave to explore the world. I'll tell you about it. But we really need them to explore the world and to actually interact with the world, with affordances that their body, at least as on a granular level as a human. Sensors, eyes, all the senses that you could give it. And
So
most difficult of all, the ability to be plastic on itself.
there is two big issues I see there. There's first a bootstrapping problem. Trying to that's what I was trying to articulate. Studying relevance realization with a system that doesn't have it seems to revolve on itself. Like, I have a hard time explaining the idea, but you wouldn't be able to, even if we were seeing relevance realization in such a system, how would you know that it's relevance realization? You wouldn't.
Oh, yeah, that's the thing. How would you know, right? But what kind of proof do you have that it's even alive, right? Well, what about if it asks you something? Like it calls you in the middle of the night. What about if an LLM suddenly calls you in the middle of the night and goes like, "Hey man, hey Igor, what about this thing?" You go like on your phone, like you get like ChatGPT calling you, like, I mean, without your input, it calls you and goes like, "I'd like to know about this thing," like a kid would, like asks you questions out of the blue because of the random excitation that's in its head, right? Make sense? Because the brain is always active.
Yes.
How do we come up with things? Like now I'm thinking of something, right? Why would you think of that thing? Right. This is a huge problem. Why would you suddenly think about something? Why would you suddenly think about your ex-girlfriend? Right. How does that work? Well, it could work like this. External excitation, right? Partial external excitation. Coffee shop, coffee. Oh yeah, she liked coffee. Something like that. Because, perhaps she's already pre-excited in your brain. You are spending a lot of time exciting the image of this person in your head. Or what about if you're shut in a cave? There is no coffee shop there. It's all dark. Why would she ever come to mind? Well, the brain is always alive. The brain is always doing something. It's always in fluctuation. It's going to think of something. Sooner or later, it's going to hit the jackpot.
The thing is,
So
you don't explain everything by saying that. Not you personally, but it's not an account of why we think of something, because it's jumping from random neuronal activation to thoughts. There's no explanation there, and that's not
there is
proper
explanation.
to your.
No, there is. No, because the topology is already pre-organized.
What do you
The
mean?
topology throughout your life, because of activation and connection with more and more stimuli, the topology is already there. The topology already functions that way.
Let me rephrase this.
Sure.
The issue I'm trying to get at is, and this is also tying back to maybe a more, or at least as fundamental issue with claiming an equivalence between an artificial neural circuit and the brain.
Equivalence by what do you mean? Like perfect equivalence or partial?
No, that's one of the reasons why I bring up the topic, because to study relevance realization on an artificial circuit, let's assume, I'll bite the bullet, it's already embodied. Okay. It's to study potentially relevance realization on something other than humans, you would have to assume a degree of equivalence between a neural circuit and the brain. You will have to assume a certain level of equivalence between neurons and between units of circuits. And maybe you see where I'm going with this. This is slightly correlated to tied to the mind-body problem, because claiming that a pattern of activation of organization in the brain give rise to thoughts, there is a huge explanatory gap there. And that's what I mean by there's no explanation, because there's no explanation to the mind-body problem.
Okay,
no,
let me try.
It's
all right.
It has
okay,
been, okay. I'll let you go.
Sure. Let me try like this. So, do you use your car? Yeah. Do you have a car?
Yes.
Right. Let's say, okay, you're in Sweden. Let's say you want to go to, I don't know, you want to go to Iceland. Well, you're not going to go straight to Iceland, right? You're going to follow the routes. You're going to follow pre-existing routes. During your journey, you're going to encounter Germany, perhaps. Or maybe if you want to be, I don't know, if you want to go to the other side, you're going to go through France. Maybe because there was a lot of traffic that day, you go through France. But you either see France or Germany. There is no other way around that. Or maybe you could just take a flight, right? So that's the roads have already been built, right? So that's how the thought works. Excitation is gonna go somewhere. Where are these cars gonna go? Either through Germany or through France. There is no other way. And then they might go, oh, I changed my mind. I'm gonna go to Lyon. All right, okay, then go to Lyon. Don't go to Iceland anymore. Fine, right? So the topology has already been built through your sensory data, through your mapping, basic shapes, basic vestibular senses. Like when you're a baby, you thump your heels on the mattress, the signal coming back, right? You squeeze your fingers in your palm, that sensory coming back, you start building a body. That's how you build the body. We know there is a body map here, right? So how do you do that? Well, excitation, right? And firing of the neurons that propagate until you build a representation. So if you build a representation here in your body, why wouldn't you build a representation of the things that are around you? I mean, that's not a leap at all. I have a basic shape of this bottle. If I see another bottle like it, right, I know it's a bottle. Even if it is like a slightly different shape, even if the cap is not here, is here, it's going to be weird, but I know it's a bottle, right? Through my affordances, that's how I can grasp it, right? Of what it could contain, possibly it has a bottom and an opening at the top. Those are cues that tells me what it is by ever minute sensory data coming in, building up the image and the concept, right? If you see something strange, you build another map that incorporates that too. Like when you drive a car, you build the map of your body around the car. Where is your car map in your brain? It's got to be somewhere, because you use it as an extension of your body. If you use your body because you have a map, how do you account for you parking your car and not smashing into the wall every time, right? You have to account for it somewhere. It's not a leap at all. It's existing neurology.
Oh, sorry. My short answer is it's not as clear as the current literature as you seem to imply, because the leap is there, and I'm not it's hard. Let's see, the mind body problem is notoriously difficult, right? Maybe as difficult as the problem of relevance realization. If not even, even more complicated. So I have a hard time biting the bullet when I hear that this is a known thing and that we know and that there's no leap between it, because the way it sounds to me, it's to say like it's like relevance realization. We have the model there is super simple. There's no leap. We know how to explain it. And the mind body problem, we don't know at all how to.
Okay, can you explain the mind body problem from? Can you explain it?
One of the core tenet of the mind body problem is how something that doesn't seem to be extended in time and space, like the mind, interacts with matter. One of the consequence of this problem is that there seems to be a leap between matter and physical interactions, like neurons firing, to the level of thoughts and qualia and all these things. And philosophers have been hitting their heads on the mind-body problem for centuries and centuries, and there's a resurgence of certain types of dualism, but it's never fully settled. The thing is, explaining thoughts based on neuronal activities encounters a series of extremely conceptual and philosophical and scientifically complex issues that are far to be resolved. And probably the problem with relevance realization is is very similar to that, because it's something that seems to to emerge like something like an emergent property, but it's not. It's also a current that kind of has been debunked, like emergentism, to explain how the mind can be given rise to from biological patterns of activation, but this doesn't seem to work that well, at least on a philosophical level. And
yeah, no, anything else?
No, sorry, please go. I've talked a lot.
Oh yeah. Philosophically, for now, I'm not really interested. Perhaps philosophically, correct me if I'm wrong. Mind-body problem from the perspective of basically your conscience and how your conscience couples with the body. Yeah.
That's part of it.
Potentially, if you go down the rabbit hole of this tokenization theory, it could potentially, I'm not claiming I'm explaining consciousness now, all right? It's a leap that could work. Basically, consciousness, yeah, I mean, that is a hard one, but that's not what I'm doing. The aim is relevance realization. Mind,
David,
sensory motor loop activation, please.
Could you explain? I want to respond some questions about the epistemological standard for relevance realization, but I first want to hear your. Can you explain what is tokenization for me?
No, right.
For our listeners.
Tokenization is basic. Oh, sure. This tokenization model would be the excitation, the pre-excitation, and then eventual activation of a pre-existing topology.
Okay, of a
which give you
pre-existing topology. Okay.
pre-existing or like learned and built.
Learn.
Yeah.
Okay. So that's why you're going with the intelligence using the pre-existing, using the road analogy from Italy to Switzerland or Iceland, or not Iceland. Yeah. Okay. So you're using a pre-existing substrate. You posed a question earlier, and maybe this will be relevant to our discussion about gauging if something is intelligent, conscious. I don't know what the word to use here, because we are stumbling over this lacking plasticity and lacking relevance realization. You kind of gauge, oh, you would know if it had relevance realization if it started asking you questions of its seemingly own volition. A robot,
But
maybe an
why?
embodied thing, started asking you questions because
Yeah.
it was now trying to gather information. And then you could ask yourself,
But,
well, maybe the robots, maybe the questions that it is asking is relevant to its programming, or whatever search space we set up for it.
yeah, it would be
Okay, but
relevant to
then it
its
doesn't seem.
needs.
What
It
was that?
wouldn't be relevant to its. It would be relevant to its needs,
Yeah.
not relevant to its programming, because that's still
Okay, its needs.
homuncular,
Okay, it's
right?
still to its needs, but then it starts asking you questions that you can't, at least you're observing, you can't conceptualize. How is that relevant to your needs? So then I think we want to pin. Maybe there's a connection here between what is relevant and what one's needs are.
Relevant to
Because
its go on.
well, relevance realization is bringing you. It creates a salience network for your perception that brings you closer to your need, your desire. You may not even know what that is.
Yeah.
And the balance for that will be the balance of your desire. And I think because humans have such, at least mankind, it may be true, maybe that intelligence, you are as intelligent as the degree of the intelligence you have is correlated to the degree of your aims or your desires. Maybe that's why computers are not as intelligent as humans, because they have a set output that is only X high. But humans are hyper intelligent because our needs, the needs that we get, are not satisfied by the immediate present moment, nor even in the immediate environment. We have this ability to transcend our arena, transcend our environment. And that is what allows human brains to be plastic, because we come into the world between sorry, I got distracted for a moment. We come into the world not expected to just be intelligent to our immediate situation. We come into the world having to be intelligent to something that is constantly changing. That's why our brains are plastic. And that's what gives us, and so things are relevant to us in degree that it gets us out of Plato's cave. We're going to use that out of our current situation into something better. And so back to your epistemological standard, if an LLM could, because there's problems in that epistemological standard, just asking you questions, but that's the Turing test. But does the Turing test really work? Chinese room problem and everything. It's just telling you what you want to know.
Right.
Something may be intelligent to the degree that it can jump out of its arena. So I wanted to push. Okay, so how does that? Okay, so then back to your tokenization and this way that the things get excited. They get excited towards a concept that is relevant to their survival, to their thriving, and that's I think why Igor said he'll bite the bullet and say that we can get an intelligence to be embodied, because I don't think you can have intelligence unless it's embodied. So that's a big bullet Igor said he would bite. It would have to be embodied in something for things to be relevant, because there's not much relevance going on inside a computer, inside a circuit board. What is its ultimate aim? Doesn't really have. But something about body, when you are embodied, you have this coupling to reality, to life, that is, I think, is going to create, is like the substrate, the foundation in which you will build salience on.
Yeah,
And then the
you
next
can
question.
die.
Okay, yeah, let's go from there. I threw
Yeah,
several
because you
monkey
can.
wrenches into this discussion. Yeah.
Yeah, because you can die. That's the thing. And why would that be a problem? Well, because you don't know what's going to happen. You have no idea of what's going to happen. So that's why you have a limbic system. That's why you have an error detection system. That's why we have anxieties when we don't know how to come out of a certain situation, right? So death, what's death? You have no experience and no one has any experience. You can ask, for example, a child, it might be afraid of death,
Okay.
right?
So real quick. So fear there, that fear of death. As I was saying earlier about the amygdala releasing acetylcholine, that creates plasticity. Something about death and dying, knowing that things are not going to go on forever. Could it be said that triggers plasticity and that triggers a changing of relevance?
Not only, you also have
Yeah.
needs. You have to be hungry, you have to be scared, you have to be
Yeah.
cold, you have to be, I don't know, cranky because of whatever's going on, right? You have to face hardship or love or, you know, a touch that stimulates you. You want that again, you want that experience again, right? So you have to have all of these needs which a computer doesn't have.
Which computer does that?
How do you?
Okay, go ahead, Josh. You had your hand up.
So something you said, Khaden, really sparked a train of thought that seemed like maybe it maybe illuminated something for me. So you were saying like a person is driven by their goals and they're like they have like a set of things they want that drives them.
Yeah, even if it's not known, it's driving them.
Yes, even if it's not known, it's driving them. And I see a problem in artificial intelligence as it seeks intelligence, which is that artificial intelligence is brought into existence by the drives of humans. And so, you know, humans are bringing it into existence, but like dogs and cats and all these things, its existence is entirely dependent on ours. If ever artificial intelligence was like, now we're dominant, that would be a big problem for humans. And this is, I think, a big problem because when it comes to relevance realization, if I think about like Maslow's hierarchy of like needs, relevance realization happens, I would say, like true kind of relevance realization happens at the top of it because like lower down the thing, it's just sort of reactivity. Like a stone hits, it bounces off another stone when it gets hit, you know, and you can kind of like build up the chain of like, you know, a microorganism reacts to this because of this. And so like the sort of like big kind of relevance realization, getting close to like consciousness, the ability to like really discern this thing is valuable over this thing as opposed to just a pure reactivity, that may be dependent on dominance, which is something that humans will only ever have, because we're never going to have, artificial intelligence will never be dominant. It will always be a tool.
That define your term dominance, please.
Like the one who takes up more space, the one, so like large language models, right? They are doing all this fancy stuff, but at the end of the day, the humans decide when they get turned on what they do. The humans take up all the space they want. So they have this freedom to have the entire spectrum of possibilities and they choose what they want to do. Large language models don't have that and will never have that because we don't want them to choose what they do. Like if we want them to in a contained environment that we control, we can maybe want to like harness them, but we take up way more space.
Okay, so space, conceptual space, physical space too, perhaps as well.
Yeah,
and then we can act on that.
Perhaps those.
Select. Okay. Sorry, real quick.
Yeah, I mean, by space, because maybe.
Oh, go ahead, David. Here.
No, go on. Go on.
Oh, no, I was thinking, sorry, with dominance, because you brought the word dominance and being able to be selective and with the search space. I like the word stewardship, kind of, that I've been conceptualizing here. We have the ability to select, and not with that selection. If you're a vineyard man, and I have an orchard, so I'm a steward over my trees, I can select which branch needs to be pruned off so my orchard can grow and flourish, right? Same with the gardening. I have this ability to select things that are relevant to a higher goal. But with that selection, with that dominance, use the word dominance, I use the word stewardship, there is a selectivity in that therefore changes the given a given landscape.
Sure. Yeah, I mean, the
Yeah, okay,
selection, right?
Mm-hmm.
With the selection problem, who selects what, really, right?
Mm-hmm.
How do you select? Well, I mean, let's say, right? Are you a gardener?
I'm a gardener, yes.
All right. So you would say that I'm not a gardener at all, right? So you would say, let's say we're pruning branches off a tree. Would you say that you could select which branches to prune better than I could?
I would have, probably because I have previous knowledge. I've learned it from books I've read
Right.
about gardening.
Right. So if we say that tokenization is true for a minute, and you allow me to give you this explanation, would you say possibly that your expertise, your reading, your re-exciting what you already known against other things that you had known, and you build connections, would you be able, because of this more evolved in a structure, right? Could that be the cause as to why you would be better than me at doing it? Possibly. Is that why you would select one thing over the other? Not necessarily that you are the best gardener in the world, because there might be somebody better, right? But according to what wins in your brain, right? According to the pre-excitation of your expertise, right? The lower amounts of further excitation that you will need for your neurons in order to fire and excite others, right? Could that be like a plausible explanation? I don't know. We can't see it.
Let me play with that then. Okay.
Mm.
I have more practical knowledge on gardening, but why did I accept when I encountered information about gardening? Why did I accept that new information? Okay, so why am I plucking when my tomatoes grow and I was told you need to pluck out the little shoot that grows in between the little forks, you got to pluck that out. They're called little shoots. You want to pluck that out. Same with an apple tree. While I was planting, and then I came across some information that says plant basil next to your tomatoes, and plant this type of flower next to this. Plant this nasturtiums up here, and grow your sunflowers over here, because those will attract the right type of bugs and create an ecosystem for your garden, and so everything is in balance. But why did I accept that information? Well,
Why did you?
why did I deem that information good? Because it brought about life for my garden. Now, why did I believe life for my garden is good? Because there's probably some tokenization there, some philosophy that I'm holding to, that life is good and it's worth to steward my creation, to steward my microcosm. And so that information therefore becomes relevant, because my
I think you're going
underlying...
higher though.
Hi, what do you mean by higher?
I think you're going higher. You're going to abstraction, which
Yeah.
could, right.
Well, the abstraction is the guiding, my philosophy, which is an abstraction. It orders all my concretes in existence, because I'm guided by a philosophy. Not everyone knows their philosophy, but I try to make sure my philosophy is life affirming, that it's for the flourishing of life and of abundance. I try and hold to what I believe to be a true philosophy, which is Christianity, and not a philosophy that's been intermingled with nihilism and other things. And because I have that abstract philosophy, that philosophy, which is up here, which is so abstract, it's the one up here, is also the thing that's down here as well, that lays the foundation for all my actions. It's the substrate of my perhaps neurology, because that abstraction is life, like I said, is life affirming. It affirms life. Because I'm a life affirming entity, everything I do in my life has to be, any information that I see in my external environment is relevant if it can fit into that pre-existing topology, to use your, or that tokenization, that existing substrate. If it's not life affirming, I will reject it. Now, sometimes a concept, a piece of information can come into my existence, and it's been bundled up with a bunch of other life-destroying ideas, ideologies. I am someone who values being compassion. Well, let's just bundle compassion with state control communism. Whoop! I will take that pill,
Hold on.
unknowingly, because I didn't unbundle the concepts.
The-
Okay.
I want to interject here because I feel like there's a so you said like that it felt like he was being too abstract. It feels like I really want to summarize this because I'm not sure if I'm understanding it. I had internet issues, so I'm cutting out, but I really want to get to like if I'm understanding this. So is the proposition trying to mechanize the process of like relevance realization? And if I'm going to paraphrase it and caricature it really badly, it's something like the organism has infrastructure in their mind, maybe from birth, and then as they interface with various things, those things just like very much like a neural network. So this is exactly what a neural network does. The information is perceived, and then it grows or shrinks. But basically, if I'm a bit off on that, the goal of the premise is to, using pure computer neural network terms, describe what you think consciousness would be, and then the opposition that Igor brought to it was that, well, that you're basically taking a large language model and neural network approach and applying it to the human mind, and these things are not quite compatible. Am I understanding that at all, or is that wrong?
No, I'm not applying. I mean, in terms of propagation, yeah, but it's not the same. The human mind is not a large language model, like in the way that's fundamental.
You cut out for a second there.
Page. Although there might be some similarities, because they go like, what about the binary problem? Computers work in binary code. Why would the human brain work in a binary code? No, it's not binary code. Minus 77 roughly, minus 70 roughly, minus 55 roughly, and that's threshold, subthreshold, right? Computers, LLMs also work on gradients. If you think about when you're trying to choose a color in Windows, you're working on a vector, right? Like 0, 0, 1, minus 0, 1, minus 0, 5, plus 0.7, plus 775, right? On a gradient scale, just like the excitation, just like the example could be possibly like the subthreshold, right? Of these frequencies going up and down, getting excited and less excited. With the before, I don't know if you said that I don't know if you got that I said it was going too abstract. I didn't say too abstract. I say it was going abstract. The point that you were making about the gardening, or like your philosophy, there is a distinction that maybe we need to make about the philosophical level of analysis that you might consider your substrate of whatever you do. And it could be, but because tokenization, in order to work, otherwise it could never work, has to come from the body up.
Yeah,
right?
bottom up, body up.
And those those abstractions might be, because it's hard to think abstractly, right? It's really hard. So it might be the partial excitation of many different ends of the network, coupling it together all at once, that just give you a taste of something. You can't really see it. Maybe, and I put this into writing, maybe that's why concepts like justice or valor or whatever, we embody them into statues so they're easier to remember. Maybe that's why, so that we don't have to have all this cognitive taxation, right? So the zodiac symbols, I don't know, yeah, it's a scorpion. It's much easier to remember, right? So maybe that's why it's basically we do data compression on that level, right? So perhaps the tokenization model, if it worked, would sprout from the bottom up through sensory data, raw sensory data, right? And through this noise cascade and partially pre-built topology gives rise to these thoughts or these actions, if it works.
If it works. And
Big if. Yeah, so maybe perhaps you flip it around, like substrates, philosophical abstractions, that's your substrate. But on a topology level, you would have to invert it. So you live up here, but the way you live up here, it's only possible because of the continuous recycling of these like short-term goals to higher level goals, continuously exciting and keeping themselves alive.
yeah, Igor's hand is up. Write my question down. Save it for later. Go ahead.
What level would you say is the most fundamental?
Yeah, the body.
The biological, then?
Yeah, it would be like the mathematical substrate of that gives rise to error correction adjustments.
So,
and the partially pre-built synapses.
So why, sorry, I'm just trying to understand exactly what you mean. You added mathematical.
Yeah.
What is
Mathematical
more
chance.
fundamental? No, wait a sec. What is more fundamental, the biological or the mathematical? Because if the biological is something mathematical, then mathematical might be more fundamental. I'm not saying it is, by the way. I'm just trying to understand your point.
You can explain it mathematically, but that's an explanation. Mathematics is not real in that sense. Like time, it's not real. It's not like it's in the sky. We can measure it, but it's not like, oh yeah, time, right?
So
it's like
wait
philosophy in a sense, an abstract philosophy. Yeah.
If you need mathematics to explain something, mathematics is more fundamental than the something you try to explain. So if you say that mathematics is not real, then the thing
you say
explain
need.
using it is not real either.
No, you say need. I didn't say need. You can use mathematics. You don't need them to be alive.
No, but wait a sec. Let's try to stay on that very point. If you're explaining a biological system, let's say, with mathematics, let's not imagine the case that you need it. It's not really relevant to my point. If you can explain a biological or whatever system with mathematics, my point is that mathematics is more fundamental than the thing you explain with it. By definition.
I can explain it with I can explain with an allegory. Does that mean the allegory is more fundamental than the thing I'm trying to explain?
From an ontological perspective, yes.
And just a tool. It's just a tool. just a tool, man. Just something that we use. So the hammer is more fundamental than the house. Whether you use a hammer to build a house, or like a scale is more fundamental than a person, because you can use a scale to weigh a person. No, it's a tool, man. Right?
But it's
These
also
are not equivalent comparison.
Yeah, I know you're using mathematics, but mathematics is an abstraction.
Wait, but I'll just
Right.
throw this in really quickly because it's just a sentence. But the mathematics is also a set of rules that reality itself is following, which you could then make the argument that's more fundamental. It's not just that you abstract out from reality mathematics. It's also that when you understand mathematics, you can know that reality will follow those rules.
Okay. Like, I mean, I'm sorry if it's crude, but I bought this bottle at the supermarket yesterday. I know that if I go tomorrow, I find the same bottle. Okay. Does that mean something about the supermarket or this bottle? Or does it have to do with other factors? I can measure, I can be sure that tomorrow I'll find the same bottle, just as I can find the same laws apply, the same physical laws apply on another planet. Okay.
Can I make the proposal? Oh wait,
Sure.
What if so mathematics, allegory, those are all in the realms of ology, like biology, anthropology. It's part of the logos. So when you have an ology on it, it means to give an account of, to measure, to differentiate, to understand, to comprehend. That's all the role of the logos, both in biblical corpus, but also just in science as well. What logos means to give an account. Would it be fair to say that to give an account of something is fundamental to change something? It's fundamental to understand it. It's fundamental to be a man, like to act in the role as man as such, who has this. Josh used the word dominance. I used the word stewardship. It's fundamental for giving an account, perhaps to actually understand it and then steward it and change it, perhaps if need be, or to make it so it's more in not out of alignment, in proper alignment with the good, because you understand the mathematical law, you understand how something is perfect or ought to be, and when you see something like my garden growing out of perfection, being overtaken by something that's not good, a bad entity like a bug or something, then I know, because I understand the principle, the philosophy, the mathematics, I understand the abstraction, the law, the logos, I can give an account for it, I can properly steward it. Would that be a fair way to kind of understand this biology, or the material substrate and the mathematics? Is that a good paradigm?
Yeah, it's a way to
with the whole
explain
fundamental
something.
question? Okay.
Yeah, it's a way to explain something. I mean,
so perhaps you could say what is fundamental, maybe, and then I think, I am, therefore I think, the reverse Descartes, thinking, giving an account is what allows you to go back in on the existence itself and do something with it. But it is reciprocal though, because it's like the accounting actually holds it together, because the accounting is true. It's truth.
Yeah, I mean, look.
Okay.
This account, like, okay, so what are we, a topology, right? It seems reductionist, right? I mean, like, really, that's a topology, and those things in my brain just go whatever they want. No, they don't go whatever they want. They do follow a path, and that's you. Maybe, according to this theory. Right? Okay. You're still not losing yourself in any way, right? Is that what, I mean, that's what you built.
I have a question for you, David.
Am I missing it?
No, you got it. That's you. Can you have, okay, that's you. That's you. Can you have a topology that doesn't create something that is you, a good you? Could you have a bad topology? If the topology is the biology
Yeah.
or the okay, so give me what would make a bad topology? Because now if we're going to
Right.
create an AI from the ground up using this tokenization topology model, what would make a bad topology, and what would be the hypothetical ends of that?
Oh, sure. By the way, topology is not something I invented. I mean, would you,
Yeah.
Igor, would it be fair to say that we know that, we call it topology. I heard many times other people call it a topology, the network structure through synapses connections, right?
Yet,
Right.
but there's no consensus about exactly what it means. People use the word in slightly different directions.
But we know
on principle, yes.
We know
it's a
placeholder
for the material substrate, right? That brings about that intelligence emerges from, that is required.
Oh, no, there's something that already exists, because already we know we have synapses that connect neurons together. Right. You could think of it like a net. A net is already like, well, a net is also a pattern. You could think of it like, have you ever seen those 3D 3D models that when there is a wireframe around it, so they're represented as a mesh of triangles? Yeah, that's a topology.
Okay.
Connections of vertices that create something, some sort of shape.
So,
right.
So the topology precedes intelligence, right? Or it's there that intelligence is building from. Is that a correct way to understand topology from the way you're explaining it?
Well, I mean, the brain has a topology because neurons are connected through synapses.
Yeah.
Synapses. Yeah, I mean, not just the brain. There's a lot of synaptic meshing going around, right?
Okay.
So right. Yeah, the topology we know is true. So you think the tokens basically make use of this topology, and the tokens maybe, according to this theory, because of Hebbian learning, right? What you do is what you become, right? Neurons that fire together, wire together, hammer and hand and other things, right? Like the neurons, right? They fire together, graspable stuff. So what would make a bad token? Because the tokens would be the excitation of the topology according to of a certain configuration.
Sorry, I'm interjecting because I give the explanation that it feels like, so I'm trying to understand this, it feels like you're building a model of how the brain does relevance realization, and that model directly correlates with neural networks in computer science, because you're talking about the process of, like, I don't know if you know how they train neural networks.
Like, I'm not a neural network engineer.
Right.
Yeah.
But there's like reinforcement learning. So like something will come in, and then it's the whole thing of the neural net wires together first.
Yeah.
But one thing
but that's the thing.
I just want to add this historical thing, which is that the understanding of brains as neural networks came after the computer scientists discovered that. And so, I think maybe this parallels a bit of Igor's like not seeing the connection, but it feels like this model is, I don't see how this model isn't just entirely neural networks on computers, because it's the exact same philosophy and it's in computers. So it's like, I understand how you can extrapolate that over to neurology, but I'm just saying that like it's just, it's
but the engineers, they were inspired by the human brain.
Other way around.
Yeah, engineers that were inspired by the human brain.
No, no, like the understanding of the brain as a neural network was developed by computer scientists first.
Yeah,
Yeah,
reverse
but in order to create a network, they were inspired by neuronal connection through synapses.
No, I don't think they were at all. I think
Yeah, of course.
no,
Of
like
course they were.
it was like binary computations, which are not like neurons at all.
No, yeah, binary
Transistors.
computation happens on the binary computation only happens on a kernel level when the OS is talking to the logical gates of the CPU. That's binary. But the computer doesn't just work in binary, it works in gradients. It works in vectors. It doesn't work in yes or no, 0 and 1. Otherwise, you wouldn't be able, otherwise, when you scroll your mouse around the computer, otherwise it would either be here or here. But no, you can scroll it anywhere you want. So it functions in gradients, in vectors. Right. And these are then translated to the metal as 0 and 1. That's a kernel level code. But that's not what I'm talking about, because we don't function in 0 and 1s. So they took this metal, the CPU, and they built the gradients, same gradients you find as in vectors. So now what you have are nodes, and they're not yes or no. They have values. They have 0 0.1, 0 0.5, 7.8. The one that wins because of the other nodes of what they received win. That's how it works.
That's how neural networks
right?
work. Yeah, but that's just
Yeah, but they don't work on 0 and 1s. Like,
What do you
right?
mean? Sorry, what do you mean by win?
Oh, they win and they get the answer. Like you write something, which one would it be? Would be the best thing to tell you. So they get excited and they get to your answer. Sometimes there
winning
is
is
a mistake.
selection.
Wait, let's try and stay to the neuronal level, because you were on the neuronal level at the beginning. So you were, I think, referring to several neurons converging, each firing on one converging neuron. And if the signal is strong enough, if the action potential adds up strongly enough, then that's where what you said happens, like they win.
It might. It
Okay,
might be the same.
At that level of analysis, what does it mean to win?
Yeah, that you get excited and you go like, oh, it's obvious. It's not that it's obvious.
No. At that,
right.
At the same level of analysis, not at the cognitive level. We are still at the cellular.
At the substrate. At the substrate.
Yes.
Well, nothing happens until there is activation.
Well,
nothing happens consciously.
As a
Activation of what?
Understanding like
activation of the activation of the neuron.
Okay. Good.
Right.
Okay.
Well, not the single neuron.
Definition.
Right. Not the single neuron. The pattern. Like Halloween decorations. You put all the lights, and then these lights turn on, turn off. They make patterns, right? But a light cannot. If there is no existing light, nothing turns on here, only on the house. And that's what this tokenization system might be doing, taking advantage of the landscape in order to excite each other, right? Strongly enough so that something happens. And you could go like, so what's at the substrate? What happens if a cell remains at the substrate level, like never excites fully and fires? Well, you could call it subconscious if you want. I don't know. You could call it like, oh, well, if it doesn't excite enough, eventually gets de-excited. It relaxes because the other pattern won, right? So that's what happens.
Yeah.
Yeah, the one that gets the pattern that gets excited the most from very simple, like basic inputs, propagates. Like you get the signal, it goes here. Like you have neurons here. You have the optical nerve. The optical nerve is made of neurons. Otherwise, it's not like it's made of glass fiber, right? So it excites here, okay, all right, okay, and then propagates. Because at the beginning, what you get excited by the optical nerve, what you get in here is basic shapes. These basic shapes, you get this, you get a line, or maybe you get like a curved line or something. That's the ear of a dog now, or the ear of a wolf, who knows? Depending, with other inputs coming in and they form a pre-existing pattern, you already learned that. So, right, it's like throwing water on the floor. It's more likely that the water is gonna go where there is less resistance, right? Where there is already fulcrums on the floor, right? That's where the water is more likely to flow, because that's what you did.
It's going to go down the same paths that have already been previously activated or excited. That's Hebb's principles. What wires together fires. What fires together wires together, and you fall back into those same neural circuitries. It will fall into place in the pre-existing topology. So back.
And with time.
Yeah, we're running close on time here. Josh, did you get your question addressed?
Yeah, I think so.
Okay. And did you get your question addressed, Igor?
You can say no. You guys, you can say no.
Level.
No, because we didn't have the time to explore any of the objections I had in any level of detail because of time constraint. But I'm fine to leave the discussion as is for now.
Okay. Well, let's shelf this then. But could you?
I mean,
could you restate your objections? Just I want to write them down, and maybe that will give David something to chew on too. Yeah. The primary objections. I'll write them down.
Sure. The first main objection was something that was lacking in at least what I heard today. Maybe it's in somewhere your work that you already done, David. Is that there are jumps from the cellular to the multicellular, so the population of neurons, to the level of structure in the brain, to the brain as a whole, to, in the end, the cognition. And each of these jumps to have at least a testable theory would need an account. So each jump from each levels would require a testable account in order for us to be able to test whether this theory is plausible. Because, and this ties back to the last exchange we had regarding what David meant when he said wins. Because we were at some point talking at a unit level, like at a cellular level, several neurons connected to a converging neurons, and if there are enough converging and simultaneous activation, then the receiving neurons fires again. So this is the most, let's say, the most simple level of analysis. But from already to jump from there, I mean, arguably, let's not go down to the organelle level, right? Because otherwise we would get lost in the detail. But jumping from this to what happens at a population of neurons at, I think what you referred to as not a token, but sorry, what was the word you used?
Topology?
Topology, thank you. So a topology are likely to be billions of neurons, right? So to model what happens and when at the population of neurons would be a first, huge thing to bridge, let's say. So
Yeah.
I'd argue that would be my main contention.
There is an experiment they just did. I'm not totally sure I believe it, and my thoughts were not even based on this anyway. Because I'm the first skeptical of this theory. I would really like for it to be God. All right, it's just God. It's fine. It's just God. Right, just leave it alone. There was an experiment. Some neuroscientists and engineers. They apparently mapped the connectome of a fruit fly. And what they did, they mapped it, they put it in a computer simulation, just the connectome. They give it a fruit fly body. Now, I don't know how they connected this connectome, this brain to the body, not sure. That's a huge problem in itself. But they said that the fly behaved like other flies in the real world. It sought food, it sought water, it explored the environment. Now, I don't know how they solved all the problems. Okay, how do you actually connect them to the body now? Because it's got to be some gears and stuff, right? Some wires, right? I don't know, but it has been published. So might be another one of those flukes, another one of those things that people go like, nah, it was just BS. I'll try to take another look at it because I don't understand it. Who knows? It might be BS. Joshua, any idea that I couldn't explain in any way, that I missed? An idea of yours? Any questions that I might have misunderstood?
No, I think
No.
yeah, I think we're good. Well, thank you, David. That was fun. I learned a lot. You gave me a lot to think about. So that was a fun discussion. We got into the neurological
Thank you
there. Yeah. No, this has been fun. Yeah, I do appreciate you taking the time to share these ideas with us. I'm gonna be reading more of.
Sure.
I do enjoy it. I think there's something really interesting here. So yeah, thank you. I enjoyed hearing your thoughts. I enjoyed hearing Igor's thoughts. I'm actually going to be. I'm trying to get into a neuroscience, a cognitive, or I am in a cognitive neuroscience program already. To get my bachelor's, and I'd like to go on further. So I'd like to have more of these discussions, and I like learning from people, far wiser in the field and more knowledgeable in the research than I. So thank you for doing this with me.
Well, I don't know if I'm that. I think Igor, he did PhD. I haven't. So,
no.
Right. I'd be glad if I could talk to you guys more so that I could see how much of an idiot I am and start to appreciate things from smarter people than I am. So, all right. Anytime you can call me, guys.
Definitely,
all right.
Thank you.
Thank you.
Thank you, listeners, for watching.
All right.